I'm Charles Norton. I'm from the NASA's Jet Propulsion Laboratory. I'm responsible there for formulation of our small satellite program within our Engineering and Science Directorate. And I also work for NASA's Earth Science Technology Office, where we advance technology capabilities through various platforms, most recently using CubeSats as a small satellite platform. CubeSats are becoming even more popular within government and industry, even though they started out as platforms that were developed within universities. What a CubeSat is basically it's a small spacecraft. They vary in size. The standard defines them as 10 centimeters on the side as a 1U spacecraft, but we typically will use and develop much larger, say 6U CubeSats for remote sensing in Earth, planetary, heliophysics, and astrophysics areas. These systems have many capabilities of larger satellites, but they're much reduced in size. The instruments are smaller, and they actually provide a mechanism to perform new types of observations that are not typically amenable to large satellites, such as having large distributed constellations that could coordinate higher temporal resolution of measurements, as well as greater spatial coverage. And while these platforms are increasing rapidly in capability, in fact, they're often referred to as a disruptive innovation, they're not meant to replace existing large satellites, but they can provide enhanced measurements, they could augment existing measurements, and as I mentioned before, introduce new capabilities and new types of measurements that are not amenable by the larger systems. So there's really great interest in the capability, particularly because you could have very rapid access to space using these systems, and they are a lot more cost effective. In particular, for certain scientific measurements, such as in atmospheric chemistry, instruments such as radiometers tend to be compact and low power, so they're a very natural fit for these types of systems. But even now, there's work going on in developing active sensors, such as radars, that can be used on CubeSats, as well as traditional optical imaging applications are also amenable to the platform. There's a lot of industry development in this area, a lot of commercialization work that's going on. So the potential to produce data for society and for scientific observation is really very high. These platforms are also used just to advance technology development. So sometimes you may develop a new instrument or a new sensor and you want to understand its performance in space as opposed to the laboratory. So you could very quickly and rapidly integrate these new capabilities into a CubeSat platform, get it on orbit and monitor its capabilities, and therefore raise its technology readiness level and prove its worth for future integration either in a larger spacecraft or a larger mission. One of the benefits of these small satellites is that not only is it allowing the community to become more creative in the types of missions they might pursue, but it's also allowing them to do it much more rapidly. You can go from a proposal concept to a launched mission, in as early as or as quickly as 18 months. But what's really exciting is the turnaround time through which you can go ahead and rapidly improve upon the prior concept that you had developed and get that into space, and to really advance the capability that you could use for remote sensing using these platforms. So turnaround time is really quite short compared to what you would typically do for a traditional mission. But those traditional missions are still important and will provide capabilities that are needed. And what's interesting is now people are formulating concepts where you could carry small satellites along with your larger traditional mission, and they could act as enhancements or mission multipliers to get even more science than what you had planned originally. The great thing about CubeSats is it's really allowing people to become very creative in the types of measurements that they want to make. And it's also opening up the community to new forms of observation, and it's really engaging a lot more scientists than you might typically be able to include on a single flagship mission.